Okay, today we're going to talk about graphing quadratics, midpoint, and distance, and we're going to talk about circles. Graphing a quadratic function using transformations. First thing you need to know is this is the parent graph for a quadratic, where A is your stretch or compression factor, H is the x-coordinate of the vertex, and K is the y-coordinate of the vertex. So if it's in this form, it's easy enough to be able to move that quadratic, okay? To start with, your quadratic equation with no stretch compression factor or no movement starts with 0, 1, -1, 2, -2. So I put a 0 in, I get 0. If I put a 1 in, I get 1. If I put a -1 in, I get 1. If I put a 2 in, I get 4. If I get a -2 in, I get 4. We're going to be using this when we start moving our stuff. Okay, so it normally starts at 0, 0. This, because it's your K portion and it's also your vertex, part of your vertex, the X is 0 and the Y is 3. So it moves up 1, 2, 3. We also know from our transformations that anything added to the back of a parent graph moves it up. So we're no longer at 0, 0, we're up to 3. There is no stretch factor, so we're still going to do the same thing. We're going to move 1 to the right and up 1, 1 to the left and up 1, over 2 and up 4, over 2 and up 4, and we're going to make our parabola. Nothing changes other than it being moved up. Okay, on the next one, this is being moved down 3, or my vertex is 0 because there's nothing with the squared with the h, and my k is -3. So I'm down 3. Nothing's changing in the fact that I'm still going up 1 over 1, up 1 over 1, up 2, up over 4, up 2. How about over 2 and up 4? And I just move my parabola down. On the next one, the h is -3. Now, why is it -3? Because my formula is -h. And what would I have to put in to a negative to get a positive? Another negative number, so it would have been -3. There is no k, 0. So I'm moving left 3. Anytime you add to the x, you move left. We've learned this previously. Nothing's changing with our stretch or compression factor, so it's over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4. Okay, our h in this case is 3 because it's supposed to be -h, and it is, so it's -3. K is nothing, so is right 3. Still over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4, because there's no stretch or compression factor. Anytime you subtract from x, you move it to the right. But here's my vertex, here's my vertex, here's my vertex, and here's my vertex. So not only are we doing transformations, we're finding vertices at this point. Okay, so on this next one, my h would be -3, and my k would be -2. So there's my vertex. It's going over 3 and down 2. Because in the back, it moves it down, and this moves it left. That's why the vertex moves. Nothing's changing in my stretch or compression factor. So I'm not stretching or compressing it. I'm just moving it. On the next one, the vertex would be -3, -2, because this moves it down 2 and to the left 3. So -3, -2. But I have this half in the front. That is a compression factor, which means my parabola is going to look shorter and chubbier. It doesn't get shorter, in fact, because of the absolute, the infinities, but it kind of looks shorter in your mind. So you have 0, 0, 1, 1, -1, 1, 2, 4, -2, 4. What you do is you take that factor and you multiply it by all the y's. So 0, 1/2, 1/2, 2, 2. So from this dot, I go over 1 and up 1/2, over 1 and up 1/2. I go over 2 and up 2, over 2 and up 2. So you can see it's getting fatter. That's at my compression factor. The vertex on the next one will be negative 3, positive 2, because it was moved left 3 and up 2. So negative 3, positive 2. Notice I have a stretch factor. How do I know stretch and compressed? Well, if it's between 0 and 1, it's compressed. If it's over 1, it's stretched. Okay? If it is plain 1, it isn't any of the above, it's the normal. So 0, 0, 1, 1, negative 1, 1, negative 2, 4, 2, 4. Now I multiply each of these by 2 because that's the factor that's on the front. 0, 2, 2, 8, 8. So over 1, up 2. Over 1, up 2. Over 2, up 8. Over 2, up 8. And see how much thinner it gets? It's like stretching taffy. Okay, so on the next one, we are looking at a vertex of, change back to my pen, negative 3, negative 2, because it was moved left 3 and down 2. Negative 3, negative 2. In the front, there's a negative. What that does is it flips it. It's a 1 still as my stretch factor. So I'm still going to be using 0, 0, 1, 1, negative 1, 1, negative 2, 4, negative 2, positive 2, 4. So over 1 and down 1, over 1 and down 1, over 2 and down 4, over 2 and down 4. The only difference is that it flipped it. So if the A in the front is between 0, above 0 and less than 1, it's a compression, so it's going to get fatter. If it's over 1, the A in the front, it's going to get stretched, so it's going to look thinner. If it is 1 in the front, it will not change at all. And if there's a negative in the front, it flips it over. If a number is being added to x, it moves it left. If a number is being subtracted from x, it moves it right. If a number is being added to the equation in the back, it moves it up. And if it's being subtracted from the equation in the back, it moves it down. Okay, so let's write the equation of a vertex of 2, 3 that goes through 0, negative 5. Okay, several things we need to know. The vertex is h and k. This is a point, so it must be x and y. And my formula is y equals a times x minus h squared plus k. So my y is negative 5 equals a times x, 0 minus h, 2, squared, plus k, 3. Negative 5 is equal to a times 4, because negative 2 squared is 4, plus 3. So negative 5 is equal to 4a plus 3. Subtract 3. Negative 8 equals 4a. Divide by 4. A is negative 2. Now I'm not finished. I need to write the equation. The equation has to have a filled in, h filled in, and k filled in. The x and y will change according to where on the graph you're using the x and y. There's a lot of different x and y points on the graph. Okay, now we're back to completing a square. They want us to find the vertex by completing a square. This is where, on that lesson, I showed you we want it in graphing form. So the first thing you do is move the c over. Then you take half a b, and you square it and add it to to c. Now I have x minus 2 squared equals negative 4. Square root it. This will go away. X minus 2 is equal to plus or minus 2i. Move my 2. X is equal to 2 plus 2i. It's not helping me get my vertex. Oh, that's because this is where it crosses the line. It doesn't tell me where the vertex is. When we were back here at x minus 2 squared equals negative 4, we just needed to bring the 4 back over. Now we know that the h is 2 and the k is 4, so my vertex is at 2, 4. This was a solve. This is what I needed to do to graph. But what this tells me is that this vertex is going to be opening up and it's not going to touch the x at all. It's just going up this way. So when we're completing a square and graphing, we just want to bring the c back so we have the h and the k. This does nothing other than well, it doesn't do anything with finding the vertex, but it does tell us that I have no x-intercepts. Graphing quadratics using properties. What if it's not in graphing form? Do you always want to complete a square? For most of you, the answer is going to be no. So you can use one of these two forms up here. This one is on your formula sheet, so this is the one that I'm going to be using. It's about 1 inch down from the top on the right hand side on your formula sheet, and it says to use to find the vertex when in the equations in standard form. Okay, so A is -2, B is 12, C is -5. So it says negative B, -12, over 2A. 2 times -2 is -4, 3. So my vertex, the x portion of my vertex is at 3. Now plug it in, 2 times 3 squared plus 12 times 3 minus 5. -18 plus 36 minus 5. -18 plus 36 minus 5 is 13. So my vertex is at 3, 13. So over 3 and up 13. I think I only go up 10, 11, 12, 13. So I'm going to estimate it. Now, how do I find more points? There's several. One, I can find the x-intercepts using the zero property of the quadratic formula. Or 2, I can use the y-intercept. And to do the y-intercept, I plug 0 in for x. So if I plug 0 in for x, this goes away and this goes away. So my y-intercept is 0, -5. So I go over to 0, -5, go down into 0, -5, and that's a point. Because this is your line of symmetry, there will be another point on the other side exactly the same distance away. Therefore, I have enough to graph at this point. So I always go with the y if I can first. A is A is positive 1, positive 1. Let's erase that and put positive 1. B is -8, C is 16. -8, positive 8 over 2 times 1 is 2, so 4 is my x. 4 squared minus 8 times 4 plus 16, 0. 4, 0. Now, the y-intercept would be, cross out the x, 0, 16. Oh, didn't graph that right, that's why. Let's go back. It's 4, 0, and it sits on the x-axis, which means that the x-intercepts would not do me any good. But if the y-intercept is positive 16, and this is the line of symmetry, I go over 1, 2, 3, 4, and go up the same amount, I can graph it. And like I've been telling you, if you make a mistake, don't freak out. Just go back and say, this makes no sense. What did I do wrong? Okay. A is 2, B is 6, C is 5. -6 over 2 times 2 is 4, so -3/2. So now I've got to do decimals or fractions. So 2 times -3/2 squared plus 6 times -3/2 plus 5. 2 times -3/2 squared plus 6 times -3/2 plus 5, a half. So my vertex is at -3/2, -1.5, up a half. If I go in and do my y-intercept, these cross out because it becomes 0. I go 1, 2, 3, 4, 1, 2, 3, 4, 5. I went over 1.5 and up 4.5, so I go over 1.5 and up 4.5. A is 3, B is 12, C is negative 7. Negative B over 2 times 6, 3 is 6, negative 2. Plug in a negative 2. 3 times negative 2 squared plus 12 times negative 2 minus 7. 12 minus 24 minus 7. 12 minus 24 minus 7, negative 19. I'm definitely going off my graph on this one. Negative 2, negative 19. I'm going to have to estimate it. Or get a bigger piece of graph paper, which I don't have right now. Okay, cross out, negative 7. 2, 3, 4, 5, 6, 7. Okay. Remember, it's symmetrical, so over here. And there we go. So we have a formula that we can use, y equals a times the quantity of x minus h, quantity squared, plus k, where h and k are your vertex points. Or we can use the formula y equals negative b over 2a. And from there, we can go ahead and find the x-intercept, the x-coordinate of the vertex, and plug that in for the y-coordinate. Okay, now we're moving on to midpoint and distance. Midpoint and